नमस्कार, आप सभी का स्वागत है। मैं हूं राहुल और आप देख रहे हैं पीएम ई विद्या चैनल्स और एनसीईआरटी का ऑफिशियल यूट्यूब चैनल। हम लेकर हाजिर हैं। आज आप सभी जानते हैं शुक्रवार है और 2 हफ्ते का समय गुजर चुका है। हमारी विशेष श्रृंखला वेबिनार सीरीज लिसनिंग टू लर्न यानी कि सुने और सीखें का आज 37वां सत्र है, जिसे हम लेकर हाजिर हैं आप सभी के समक्ष। हमारे साथ 2 खास मेहमान हैं। एक खास मेहमान जिनसे आप हमेशा रूबरू होते हैं और एक जो यहाँ पर अपना मत रखने आते हैं एक ऐसे विषय पर जिसकी सार्थकता होती है, जिसकी आवश्यकता होती है और जो भारत के लिए सबसे ज़्यादा आवश्यक है, चाहे वो कोई भी क्षेत्र हो, चाहे वो स्वास्थ्य का क्षेत्र हो, चाहे वो विकास का क्षेत्र हो। और आजकल यदि हम आज एक नए उभरते भारत की बात करें तो आत्मनिर्भर भारत एक ऐसा शब्द है जो हर भारतीय की जुबान पर है। और हो भी क्यों ना, अभी हाल ही में यदि हम एक सेमिनार जो आयोजित की गई थी जिसका शीर्षक था स्वावलंबन, उसमें हमारे यशस्वी प्रधानमंत्री जी ने बताया था कि जो भारत का डिफेंस एक्सपोर्ट है वो पिछले 8 साल में 7 गुना बढ़ गया है, यानी कि भारत कितना आत्मनिर्भर बन रहा है, ये इस बात की वानगी प्रस्तुत करता है। तो ऐसे खास विषय पर हमारी चर्चा करना भी बनता है क्योंकि ये हमारी भी एक नैतिक जिम्मेदारी है। मैं राहुल आप सभी का एक बार पुनः स्वागत करता हूँ। आज मैं आपको बता दूँ कि वेबिनार सीरीज लिसनिंग टू लर्न में हमारा जो टॉपिक है वो है सेल्फ रिलायंट इंडिया अ मटीरियल्स पर्सपेक्टिव। तो ये आज का हमारा खास विषय है, आत्मनिर्भर भारत पदार्थ परिप्रेक्ष्य। और हमारे साथ 2 खास मेहमान हैं, मैं आपका दोनों से परिचय करा देता हूं। हमारे साथ हैं डॉक्टर गगन गुप्ता, आप एनसीईआरटी से ही हैं, कोऑर्डिनेटर ऑफ द प्रोग्राम। गगन जी नमस्कार, आपका बहुत बहुत स्वागत है। और हमारे साथ CSIR एम्प्री, जिसे आप एडवांस मटेरियल्स एंड प्रोसेसेस रिसर्च इंस्टीट्यूट भोपाल के नाम से जानते हैं, उसके निदेशक महोदय डॉक्टर AK श्रीवास्तव जी हैं। सर नमस्कार, आपका भी बहुत बहुत स्वागत है, अभिनंदन है। आत्मनिर्भर भारत की एक ऐसी परिकल्पना जिसे साकार करने में हम सभी लगे हुए हैं और तमाम ऐसी चीज़ें हैं जो भारत आज स्वयं आत्मनिर्भर बन रहा है, बना रहा है, दूसरे देशों पर निर्भर नहीं है। तो आप गगन सर से मैं निवेदन करूंगा कि इस सत्र को आगे बढ़ाएं, हमारे जो गेस्ट हैं उनका परिचय हमारे दर्शकों से कराएं और बताएं कि इस कार्यक्रम की भूमिका को जानना समझना न सिर्फ स्टूडेंट्स के लिए बल्कि टीचर्स के लिए और जो भी स्टेक होल्डर्स हैं इस पूरे प्रोग्राम के, उनके लिए कितना आवश्यक है।
सादर प्रणाम दोस्तों, आज हमारे लिए 37वां सत्र है, हमारी सीरीज़ का 37वां सत्र है। आप अपने प्रश्न हमेशा की तरह हमारे यूट्यूब चैनल NCERT ऑफिशियल पर भेज सकते हैं। साथ साथ आप अपने प्रश्न CSIR इंडिया और CSIR एम्प्री भोपाल के यूट्यूब चैनल्स पर भी आप अपने प्रश्न हमें भेज सकते हैं। साथ साथ आप हमारे ईमेल एड्रेसेस जो कि अभी स्क्रीन पर फ्लैश किए जाएंगे, आप उन पर भी आप हमें अपने प्रश्न भेज सकते हैं, अपने सुझाव भेज सकते हैं। लगातार सुझाव भेजते रहिए, आपके सुझाव हमें इस प्रोग्राम को आगे बढ़ाने में और आगे संचालित करने में बहुत मददगार साबित हो रहे हैं। हमें लगातार आप लोगों से संस्तुति मिलती है कि इस तरह के प्रश्न को और इस तरह की जिज्ञासाओं का समावेशन किया जाए, इससे हमें साथ मिलता है। ये प्रोग्राम आज हमारा लगभग 1 साल पूरे हो रहे हैं और पिछली बार हमने 6 अगस्त 2021 से इस प्रोग्राम की शुरुआत की थी और अब तक 36वां सेशन हो चुके हैं, जिसमें कि हमने विभिन्न प्रकार के लोगों के साथ विभिन्न प्रकार के विषयों पर चर्चा की है, चाहे वो फूड हो, चाहे वो रॉकेटरी हो, चाहे वो प्लेनेटरी मिशंस हो, चाहे वो मेडिसिन हो या मटेरियल्स की बात हो। इन सब विभिन्न विषयों पर हमने बात की है। आज फिर से हमारे साथ डॉक्टर AK श्रीवास्तव, अवनीश कुमार श्रीवास्तव, जो कि CSIR एम्प्री भोपाल के निदेशक हैं, डायरेक्टर हैं, आज हमारे साथ हैं। उनका एक बहुत लंबा चौड़ा अनुभव है और बहुत लंबे चौड़े उनके विशेषताएं हैं, उनकी क्वालिफिकेशंस हैं, उन सब के बारे में बात बताऊंगा। इससे पहले थोड़ा सा मटेरियल्स के बारे में हम समझने की कोशिश करें। तो साथियों, पिछली शताब्दी का पूर्वार्ध लगभग सन 1900 से लेकर 1950 तक केंद्रित रहा एटॉमिक रिसर्च, न्यूक्लियर रिसर्च इस पर। इसके बाद में पिछली शताब्दी के पूर्वार्ध में हमने इलेक्ट्रॉनिक्स की क्रांति देखी, जिसमें कि हमने कंप्यूटर्स के बदलते हुए स्वरूप देखे। मेडिसिन्स में हमने बहुत सारे सर्जरी के उपयोग देखे, पेनिसिलिन से लेकर के हम एंटीबायोटिक्स, डिफरेंट एंटीबायोटिक्स तक पहुंच गए, एंटीवायरल मेडिसिन तक पहुंच गए। इस शताब्दी में और पिछली शताब्दी के आखिर के दिनों से ही ये महसूस किया जाने लगा कि जितने पदार्थ हमारे पास प्रकृति में हमें मिलते हैं वो उनमें विशेषताएं हैं, लेकिन जिस तरीके की विशेषताएं हमें अलग अलग अनुप्रयोगों के लिए चाहिए, उसके लिए हमें मैन मेड या मानव निर्मित पदार्थ चाहिए। आज हमारे साथ एक ऐसे ही व्यक्ति हमारे साथ हैं जो कि इन सब विषयों पर आप हमें विस्तार से बताएंगे कि किस तरह से मटेरियल रिसर्च में प्रगति हो रही है और इस आज इस मटेरियल रिसर्च को आप इस तरह से थोड़ा सा समझ सकते हैं बहुत गूढ़ शब्दों में कि रफली 60% ऑफ द इंटरनेशनल फंडिंग on research and development goes to material science for the development of new materials where we can have the properties of the materials in the desired fashion. We can tailor the materials. It is ऐसा लगता है कि आज से 20 साल के बाद या अभी से शुरुआत भी हो चुकी है कुछ कुछ जगहों पर, लेकिन आज से 20 साल के बाद जिस तरह से कि हम किसी टेलर शॉप पर जाते हैं और कहते हैं कि आप मेरे नाप का कपड़ा सिल दीजिए और उस कपड़े में ये विशेषताएं हों, और आज से कुछ वर्षों के बाद कुछ दशकों के बाद हम इस स्थिति में आने के लिए तत्पर हैं जिसमें कि एक कोई इंडस्ट्रियलिस्ट किसी रिसर्च साइंटिस्ट के पास जाए और कहे कि मुझे इस तरह का मटेरियल चाहिए कि जिसमें इसकी इतनी इलेक्ट्रिकल कंडक्टिविटी हो, इतनी डक्टिलिटी हो, ये मैकेनिकल इसकी स्ट्रेंथ हो, ये इलेक्ट्रिकल प्रॉपर्टीज हों एंड सो फार सो ऑन। तो इस सब तरीके की बात करने के लिए आज डॉक्टर श्रीवास्तव हमारे साथ हैं जो कि हमें मटेरियल रिसर्च के बारे में अपडेट करेंगे थोड़ा, और उसके बाद मुख्यतः हमारे देश में इसके लिए क्या क्या प्रयास चल रहे हैं और हमारा देश इस स्तर पर क्या क्या कर पाया है, इस सब के बारे में हमें आत्मनिर्भर बनाने के लिए इस क्षेत्र में क्या क्या विकास हो रहे हैं, क्या क्या शोध कार्य हो रहे हैं, इन सब के बारे में बताएंगे। तो इस भूमिका के साथ मैं आपका प्रोफेसर श्रीवास्तव के साथ थोड़ा सा परिचय कराना चाहता हूं। Our friend Dr. A.K. Srivastava is currently the director of Council of Scientific and Industrial Research Laboratory at Bhopal, which is called Advanced Materials and Processes Research Institute. Dr. Srivastava is an outstanding professor at the Academy of Scientific and Innovative Research, Ghaziabad, which is an institute of national importance. Professor Srivastava has earned his master's degree in physics from the Indian Institute of Technology, Roorkee, master's in technology in material science from the Indian Institute of Technology, Kanpur, and Dr. Srivastava holds the PhD degree from Indian Institute of Science, Bengaluru, in metallurgy. So this shows the diversity and the dynamicity in Professor Srivastava. Dr. Srivastava has research interests in diverse areas including materials, processing and characterization, semiconductor sciences, nanostructured materials and green engineered composites, all frontline areas. He has more than 350 research publications to his credit with more than 11,000 citations, a very huge and number which gives us a feeling of pride. He has more than 15 patents to his credit and almost identical number of know-how transfers in his credit. Dr. Srivastava has also edited several books in diverse areas. He has guided more than a dozen doctoral theses. He is also serving as the chief editor of the journal which is called Applied Innovative Research. Dr. Srivastava is presently the president of Electron Microscope Society of India, popularly called EMSI. He has also been instrumental in establishing new research facilities at CSIR's National Physical Laboratory, NPL, New Delhi, and of course at AMPRI, Bhopal. These include high resolution transmission electron microscopy, which is called HRTEM, electron energy loss spectroscopy, EELS, and indigenous Raman spectrometer with two versions called IndiRAM CTR 300 and CTR 150. Under the leadership of Professor A.K. Srivastava, CSIR-NMITLI has developed several products. We will know all about all those products today in today's session. However, to brief, this list includes X-ray radiation shielding concrete, tiles and other composite materials like red mud and brine sludge, bamboo composite, Parali composite, etc. Professor Srivastava has also been instrumental in organizing various events of traditional craft and artisan meets. A huge diversity in his interest and in his career. His international collaborations with Argonne and Brookhaven National Laboratories and United States, Technical University Darmstadt, Germany, Department of Energy, Italy, etc. have been a matter of pride for our Indian scientific community. Dr. Avanish Srivastava has several awards in his name. A few of them are the Metallurgist of the Year Award by the Ministry of Steel, Government of India, MRSI Medal, INSA COSF Fellowship, Postcast Fellowship, NRDC, and so on. Dr. Srivastava has also been a member of several committees such as TIFAC, Bureau of Indian Studies, Indian Standards, BIS, and Standing Scientific Advisory Group by the Ministry of Mines, Government of India. Such a dynamic person is with us. We are really privileged to have you, Dr. Srivastava, in our studios. It's all yours. Welcome once again.
Thank you. Thank you, Professor Gagan Gupta and your colleagues for inviting me for today's lecture at National Council of Educational Research and Training. I'm going to talk on self-reliant India, a materials perspective, as Professor Gagan Gupta just mentioned. हिंदी में हम कहते हैं आत्मनिर्भर भारत, पदार्थ परिप्रेक्ष. When we say Aatmanirbhar Bharat, we always remember the date 13th May 2020 when our Honorable Prime Minister said that country has to become self-reliant. And 5 pillars of those self-reliance is economy. Economy, he says, economy should grow with a quantum jump, not like an incremental growth. And you all know that he has targeted for the $5 trillion economy. Infrastructure, that becomes the identity of modern India. Demography, we all know, we have vibrational demography from Kashmir to Kanyakumari. We should have technology-driven system and demand, a good supply chain. So when we talk about Aatmanirbhar Bharat, self-reliant, then it is also important to synchronize this with the evolution of industry 1.0 to 4.0. Without going into the past, which industry 1.0, the mechanical production started in late 18th century. We are now in the era of industry 4.0, that is digital transformation, where we talk about the artificial intelligence, advanced robotics, 3D printing, IoTs, big data, and so on. And industry 5.0 is on doorstep, where man has to work alongside with robots. Now, what is the role of materials in the Aatmanirbhar Bharat? Materials for self-reliant is very important because whatever you make, whatever products you make, I'll show you some of the technologies. This lecture is full of video clippings. You will enjoy, I hope. So, materials for self-reliant, for promoting the original exploratory research, pioneer engineering materials, and integrate with industries and society to contribute towards the building of the nation. And when we contribute towards the building of the nation, we can definitely become the Aatmanirbhar. Now, sustainability of materials is very important. It has got 5 levers to minimize materials impact, that is lifetime extension, dematerialization, substitution, recovery, and manufacturing efficiency, where we talk about additive manufacturing and so on, those things. Now, the materials which I am going to talk and the technologies out of those materials is in following fields: metals and polymers, like aluminum metal matrix composites for brake drum for automobile industries, aluminum foam for crashworthiness, shape memory alloys, shape memory polymers. In civil infrastructure, you have radiation shielding, concrete, cement-free concrete road, hybrid wood substitute, bamboo composite. In environment, basically to use waste to wealth. Waste product, you convert it into a useful product. That is red mud and fly ash utilization into value-added products, utilization of marble waste into wood substitute, and agro waste like Parali convert into useful composites. And then next generation materials, very important thing. And processes like nanomaterials, graphene-based nanomaterials, 3D printing, and so on. Now, first example, a case study I am going to show you here, that advanced cement-free fly ash-based geopolymeric concrete. You know, fly ash, it is a waste of thermal power plants, and it comes out millions of tons, and its utilization is still under question. And India generates about 196 million ton fly ash per year. We have converted this fly ash into the cement-free concrete, because when you produce cement, equal amount of CO2 is also produced, which is not good for environment. That is one disadvantage. Then fly ash is a waste, so you are converting waste into the value added products. The salient features are it's 100% replacement of cement, water curing free process, ready for use within a week, whereas cement concrete, if you use, it takes about 28 days or a month. And bulk fly ash waste utilization, so you are converting waste into the value added products, and it's environmental friendly process. We have constructed a road, a small patch in All India Institute of Medical Sciences, Bhopal, just for demonstration purpose. It was in the year 2017 sometime, and it's working very well. Now, another waste product from the industry is a red mud, which comes out from the your alumina industries. When you convert this bauxite ore into alumina using bias process, then this red mud comes out, and this red mud is almost equal amount of the alumina which is coming out. So this is another waste product, and this red mud problem is that it has a very high alkalinity, so it's hazardous for health, it's not environmental friendly. We have converted this red mud into radiation shielding tiles, and now you will be happy to know that Dr. Harshvardhan, the cabinet minister that time, he came, 13th March 2021, and he inaugurated the Center for Advanced Radiation Shielding and Geopolymeric Materials. This is a unique center in the country, and to the best of my knowledge, this is the unique center in the world. On that basis, we also first time AMPRI received the National Research Development Corporation, NRDC, National Meritorious Invention Award. On that occasion, we made a video clipping. I'll just share with you this video clipping, which will summarize about entire process, what we have done and what we have achieved during this entire work.
CSIR Advanced Materials and Process Research Institute, in short CSIR-NMITLI at Bhopal, has been working on the development of non-toxic and lead-free material protect high-energy radiation shielding, which can be applicable from health to the strategic sectors. Mainly, CSIR-NMITLI's expertise lies on the conversion of industrial waste like red mud, fly ash, rice husk, brine sludge, etc. into radiation shielding materials by arresting their hazardous nature in a scientific manner. Billion tons of such noxious industrial waste have been piled up in the disposal plants worldwide and pose serious threat to the environment due to particulate emission, alkalinity, heavy metal leaching, etc. CSIR-NMITLI Bhopal had transferred a technology on lead-free X-ray shielding tiles to Messrs. Prince Johnson Limited on 10th June 2019 at Ansandhan Bhavan, New Delhi, in gracious presence of Dr. Shekhar C. Mande, Honorable Director General of Council of Scientific and Industrial Research, that is CSIR, and Secretary Department of Scientific and Industrial Research, that is CSIR, to the Government of India. CSIR-NMITLI has developed this novel material using the industrial waste to shield X-rays that comes out of the diagnostic X-rays, computerized tomography, CT scanner, cath lab, etc. Nearly 6 mm thick material possesses the attenuation characteristics of 1 mm lead shield. Since lead poses a serious environmental hazard, its usage is being discouraged world over. This technology is nearly 3 times cheaper than the lead, hence we use industrial waste as raw material. The radiation shielding material developed by CSIR-NMITLI Bhopal was accredited by Atomic Energy Regulatory Board, that is AERB of Government of India, and it has been reported as an alternative material of toxic lead to shielding high-energy X-ray photons. Recently, Messrs. Saideep Healthcare and Research Private Limited, Ahmednagar, Maharashtra, has used CSIR-NMITLI technology to cover the wall of their 3 X-ray diagnostic rooms, 1 CT scan room and 1 cath lab, and totally it's about 2,500 square feet. Tiles were utilized and it has been tested and approved by AERB.
I am happy to say that joint-free X-ray shielding tiles are being made at pilot scale at Messrs. Prince Johnson in collaboration with CSIR-NMITLI Bhopal. On 13th March 2021, Dr. Harshvardhan ji, Honorable Union Minister Science and Technology, Health and Family Welfare, Earth Sciences, and Vice President of Council of Scientific and Industrial Research, inaugurated the Center for Advanced Radiation Shielding and Geopolymeric Materials. On this occasion, Shri Sudipto Sahar, President Operation of Messrs. Prince Johnson, did mention that lead-free X-ray shielding red mud tiles, the product launch will be very soon, maybe within a month or so. Accordingly, we hope that our red mud radiation shielding tiles will be in market very soon. Thank you. Dhanyavad. Jai Hind. So another series of technologies which we have developed, and it's very important for the country. These are import substitutes also on hybrid green composite materials. I'll tell you some of the case studies, and the challenges are basically at present we have the challenges like find alternate materials for timber, GRP plastics, avoid deforestation. So in this regard, I'll show you one example, agro waste Parali, which at least the Delhi, Punjab, Haryana state people know very well, that during the months of October to December, to some extent January, Parali is being burned. It's a paddy straw waste, and there is no taker of Parali. We have converted this into 100% conversion into the products like laminates, panels, and it's again the alternate of wood, and the applications of this Parali wood is for making door, false ceiling, false tiles, wall tile, partition roofing, furniture, etc. In this regard, we have met several officials of Haryana and other states. Here is the example, that meeting with the Honorable Chief Minister of Haryana and then Director NIT Kurukshetra. We have transferred this technology also to Messrs. Shubh Green Sheet Private Limited. And based on this work, the DST Vigyan Prasar came forward and they made a video clipping for us to popularize this technology in countrywide. And so I would be happy to share this video clipping, and I am sure that you will enjoy this and you will see that how waste can be converted into the
बिजली घरों से निकलने वाली राख हो या फिर मार्बल का कचरा, ये सभी पर्यावरण के लिए खतरा बने हुए हैं। इस तरह के कचरे को फेंकने की जगह भी नहीं होती, लेकिन वैज्ञानिकों ने इस कचरे से प्लाई और लकड़ी का निर्माण कर समस्या का अनूठा समाधान तलाश लिया है। आइए देखते हैं रिपोर्ट।
CSIR की भोपाल स्थित प्रयोगशाला एडवांस्ड मटेरियल्स एंड प्रोसेसेस रिसर्च इंस्टीट्यूट AMPRI तथा NIT कुरुक्षेत्र के वैज्ञानिकों ने धान से निकलने वाली पराली, गेहूं के भूसे, औद्योगिक अपशिष्ट जैसे फ्लाई ऐश और मार्बल के कचरे तथा फाइबर का प्रयोग करते हुए प्लाई और लकड़ी विकसित की है। वैज्ञानिकों के द्वारा तैयार की गई लकड़ी कई मायने में फायदेमंद है, जैसे इसमें आग लगने की संभावना नहीं होती। दूसरा, ये सीलन से खराब नहीं होती और दीमक भी नहीं लगती। ये पानी से भी खराब नहीं होती है। जो उपयोग लकड़ी के हो सकते हैं वो सब इसमें होते हैं, लेकिन जलाने के उपयोग में इसे नहीं लाया जा सकता है। वास्तविक लकड़ी की तुलना में लकड़ी कहीं ज्यादा मजबूत है। AMPRI द्वारा तैयार लकड़ी में 60% कृषि और औद्योगिक अपशिष्ट मिलाया जाता है, जबकि बाकी 40% फाइबर मिलाया जाता है। CSIR ने इस तकनीक का पेटेंट भी फाइल किया है। दरअसल पंजाब हरियाणा में पराली के निपटान के लिए किसानों द्वारा उसे जलाया जाता है, जिससे समूचे NCR में प्रदूषण गंभीर रूप धारण कर चुका है। इस प्रकार बिजली घरों की राख को बहा दिए जाने से वो जमीन को बंजर बना रही है। मार्बल का कचरा भी जमीन और पर्यावरण के लिए खतरा बना हुआ है। ये तकनीक इन तीनों समस्याओं का समाधान निकालती है। इसके अलावा राष्ट्रीय वन एवं पर्यावरण नीति के तहत भी इस तकनीक का निर्माण बेहद अहम है, जिसमें भवन निर्माण के लिए वैकल्पिक लकड़ी तैयार करने पर जोर दिया गया है, जिससे वनों की कटाई कम हो।
CSIR Advanced Materials and Processes Research Institute, in short CSIR-NMITLI Bhopal, has developed a technology for making evergreen hybrid ply and composite wood using Parali and agro waste. This technology was developed with multiple objectives for multifunctional application as well as in view of effective use of Parali and agro waste. The findings of the research paves ways to introduce new materials to the society, contributing to the national policy, Government of India, for development of wood substitute for building application so that consumption of timber in building and house construction can be minimized. Furthermore, this will be a potential solution for effective utilization of different agro wastes such as paddy straw, wheat straw, etc., leading to solve various environmental threats associated with management of agro waste, deforestation, and ecological imbalance. The evergreen hybrid ply and composite wood are durable, resistant to weather, corrosion, water, moisture, and termite and fungal free composites. The composite materials are fire retardant, self-extinguishing nature, cost-effective, and maintenance-free materials. Evergreen hybrid ply and composite wood has potential to use as an alternate material for wood timber, plastic, synthetic wood such as MDF board, particle board, and plywood, and all other conventional materials used in furniture industry.
AMPRI ने हाल ही में इस तकनीक को बाजार में उतारने के लिए भिलाई की कंपनी शुभ ग्रीन शीट प्राइवेट लिमिटेड को हस्तांतरित किया है। कंपनी जल्द ही भिलाई में इसका उद्योग स्थापित करने जा रही है। वैज्ञानिकों का दावा है कि ये प्लाई और लकड़ी बाजार में मौजूद प्लाई और लकड़ी से सस्ती होगी। AMPRI के निदेशक डॉक्टर अवनीश कुमार श्रीवास्तव ने कहा कि ये प्लाई एवं लकड़ी मौजूदा उत्पादों का बेहतर विकल्प साबित होगी।
So another translational research I want to inform you here, especially it's very important for the people who are in Northeast region, the conversion of bamboo into bamboo composite. And this bamboo composite is the alternate of teak wood. You may not be able to read the properties what I have mentioned here on the screen, but the properties of the bamboo composite are either at par with the teak wood or it's better than that. In addition to that, you see the teak wood is a tree which is again a problem of cutting, and teak wood, that tree, it takes about 30 to 40 years to grow before it is ready for use. But the bamboo, it is within the 3 to 4 years it's ready to cut. So we have used that technology and made bamboo composite. It's a wood you can use, and it's very good for housing structure, Ministry of Tourism, and so on. And first construction we have made at AMPRI Bhopal itself. It's about 250 square foot area committee room, and it is fully functional now. And this was again the foundation stone was laid down by Dr. Harshvardhan ji. So this is very good technology. It is already transferred. It is commercialized. Price list is in the market, and we are in good interaction with the northeast people, especially Mizoram, Assam and all, that this kind of technologies can be implemented, and it will also lead to employment in those areas. And about 80 to 90% people, those who are even less educated, can be employed. So employment generation, eco-friendly, and our own God-gifted bamboo can be used as a bamboo composite alternate of teak wood. Then coming to metallic materials, this is aluminum composite, aluminum silicon alloy, silicon carbide composite, and this composite can replace your manhole. You know, manhole everybody has seen, and manhole so far it is being used by casting the iron. Now that manhole, and if you compare with this composite material, it is 3 times heavier. So transportation in our case, it is easy because it is 1/3 of weight. It is cost effective, and it has the improved thermal stability, better wear resistance, good corrosion resistance, and high temperature strength. So this is first time on 80th year of CSIR we have transferred this technology, and it has also come in 80 stories of CSIR in last 80 years of the findings of CSIR Technologies Compendium. Now coming to high impact science and technology development, this is also important because whatever materials we are developing, whatever science technology we are doing, we also need to think about the future, that what is the future technologies. And as I said, that 3D printing in Industry 4.0 is a very important aspect in manufacturing. We have used first time in the country making this graphene stainless steel composite, and this is better thermal exchanger, so it's good for automobile industries and so on. And we are the first in the country to publish these results in international journals of very high impact factor like additive manufacturing and material science and engineering. I'll show you some of the results related to electron microscope. This slide is blank, but it shows the high resolution transmission electron microscope. And high resolution transmission electron microscope, where the electron beam is the heart of the microscope, and you know how much time it takes for translational research. In 1897, the J.J. Thomson discovered the electron, and first transmission electron microscope was built in 1931 only. And as of now, the transmission electron microscope has the point-to-point resolution of about 0.2 nanometer. But this is another unique product I am showing here, which shows scanning helium ion microscope. So in this case, you know, normal scanning electron microscope, we use electron beam, but here instead of electron beam, helium ions are used, and now by using that helium ions, the resolution has gone 3 times better. It is 0.34 nanometer, and this result I am showing, which is about 10 years old. And using graphene sheet, using this helium ion, you can even do the nano patterning. And here you see Rashtriya Bhautik Prayogshala on graphene nano sheet is written in the length of 100 nanometer. So, and the letter gapping is about 7 nanometer. So such kind of precise measurements you can do using the helium ion microscope. And now, as I know, the first helium ion microscope, the first instrument has been already installed in India also, in Defense Metallurgical Research Laboratory, Hyderabad. To encourage our young students, I must show this slide that even in electron microscopy field, still the Nobel Prize are given. These are the people, Jacques, Joachim and Richard, who received Nobel Prize in Chemistry in 2017 for developing cryo-electron microscopy for the high-resolution structure determination of biomolecules in solution. Now, coming to our own discovery. In 1928, on 28th February, Sir C.V. Raman gave the concept and he analyzed the scattering of light, bond strength and so on. And in 1930, he received the Nobel Prize. But since 1928, on 28th February, on which that day we also celebrate National Science Day, but we procure the Raman spectrometer from abroad. We spend so much money, we procure these instruments from abroad, and it is after only 94 years, thanks to CSIR headquarters for sponsoring a project under public-private partnership to AMPRI Bhopal and Messrs Technos Instruments, that we have made the Raman spectrometers of high-end specification, which is at par with any international marked Raman spectrometer. Two models, as Professor Gagan Gupta mentioned, CTR 300 and CTR 150. And you will be happy to know that already 2 purchase orders our industry partner has received in this direction from CSIR Indian Institute of Chemical Biology and Maulana Azad National Institute of Technology, Bhopal. So in this regard, I've already told this is first Make in India Raman spectrometer after about a century that India has made. So these are the things need Make in India, Made in India, if you really want to contribute something for making the country self-reliant. So in this regard, our Honorable Director General President Dr. Rajesh Gokhale wrote a letter to several secretaries to the Government of India, and he mentions that even though the Raman effect was invented in India in 1928 and awarded the first ever Nobel Prize in Science for any Asian in the year 1930, nearly a century after the discovery in India, the country is still importing Raman spectrometers for use. Since the indigenous Raman spectrometers are now readily and commercially available in India, I therefore seek your kind intervention for wider publicity, circulation, due consideration in your department, organizations, purchase of Raman spectrometers before going for global tender inquiry. And this is already on GEM portal for the purchase of this through the industry. So this is contributing to Aatmanirbhar Bharat Abhiyan under economy, infrastructure, system, demography, and demand. I will not go line by line, but it's a real contribution towards making the country self-reliant. Now, we cannot escape nowadays any talk without talking about COVID-19. We have done a lot of work in fight against COVID-19, and CSIR headquarters had made 5 verticals: surveillance, diagnostics, drugs, hospital assistive devices, supply chain, to fight against COVID-19 for common man, and we contributed towards hospital assistive devices. So several masks, sanitizer, disinfectant boxes, 3D printed masks for doctors, and various other products we developed these days. And we also collaborated with our sister labs, CSIR Central Building Research Institute, and made first makeshift clinic in Bhopal during the first wave of COVID. Then second clinic we made in Devas, that is also in Madhya Pradesh. And third full-fledged hospital in third wave we made in Nandurbar, again that is a tribes area in Maharashtra, 30-bed hospital with 10 ICU and 20 non-ICU beds, and hospital is under full function. So before going this slide, I'll just show you in brief what we have done during this COVID period. Although this old video, but it will give you just a short feeling that how we have contributed towards fighting against COVID-19. CSIR Advanced Materials and Process Research Institute, in short we call it CSIR-NMITLI at Bhopal, is one of the constituent labs of CSIR, that is Council of Scientific and Industrial Research. Under this lab of CSIR, that is at AMPRI Bhopal, we work on lightweight materials, smart and functional materials, nanostructured materials, waste to value added materials. And these materials in turn they get converted into different outputs like publications, patents and products, that is technology know-how transfers. It's a national lab of international repute. As far as COVID-19, this pandemic of coronavirus is concerned, we worked on different directions. Being an engineering lab, we tried to do our best using our capacity, efficiency and the expertise of our scientific, technical and non-technical manpower. We worked on knowledge generation, knowledge dissemination, industry interface, societal interaction and innovative products. In terms of knowledge generation, we published some very important papers in international journals, including even considering the nanomaterials of graphene, and we are probably the first in the world to publish in Science Reporter saying that graphene can work as a protection material against coronavirus. Other publications like on antimicrobial coating, biosensors, medicinal plants and so on. Then we did knowledge dissemination, like organizing conferences, workshops, training the people and also making aware how to protect yourself, how to prevent yourself from the COVID-19. We had these programs under Jigyasa, teaching the school students, their parents, their teachers, their deputy commissioners, principals, and under a skill development program, certain programs we have run. Then we interacted with society in terms of teaching them or making aware how to protect themselves from coronavirus. In this case, we reached to more than 50 villages of Madhya Pradesh and Chhattisgarh. We distributed our masks, sanitizer, soap and posters, making them aware about the coronavirus, COVID-19. We also distributed our soaps, masks, then sanitizer and posters to government officials like police personnel, bank officials and common man. Then further we worked on different products, technologies we are trying to develop, and we started with face mask and sanitizer with extra skin care. And this technology we transferred to a startup company in Indore, and I am happy to tell you that face mask is already in the market. It's commercialized after lab testing, and sanitizer work is going on. In addition, we are working on to develop different sanitizer boxes with UV and nanomaterials, hybrid boxes, without UV with nanomaterials, hybrid boxes. We are developing some other products like some biosensors and so on. Then we are working on different other products like different high quality masks like e-mask, tribological mask, herbal mask, graphene layer incorporated mask for different sectors of the people, not only to common man but even for doctors and other healthcare people. So in total on different fields we are working. We are developing antimicrobial coating to protect ourselves from this COVID-19 coronavirus, and this coating can be used for different metallic surfaces, and therefore one can protect ourselves. So in total in 5 directions of knowledge generation, as I said, knowledge dissemination, societal interaction, industry interface and innovative projects. In all these directions our scientists, technical staff, non-technical staff, students, project fellows, we are working in one team, and we are also getting associated with CSIR as a whole. CSIR as a whole also has 5 pillars where different directions they are working, and we are associated with hospital assistive devices among 5 pillars of CSIR. With this, thank you very much. Jai Hind. Dhanyavad. So, in addition to that, we are working on to generate the skill among young students and so-called future scientists, I should say. Starting from school level, CSIR Jigyasa program is for school children. CSIR Skill Initiative Development Program for young researchers, engineers, and faculty development program under artificial intelligence sponsored by AICTE. So these are the programs are going parallelly in addition to the fundamental research and translational research which we are doing. And these are the glimpses of some of the programs we conducted under CSIR Jigyasa. And I'm happy to inform from this forum that in last 4 to 5 years, we have reached more than 1 lakh students, faculties, their principals, deputy commissioners, assistant commissioners, and so on, during the programs conducted online and offline as well. We have published several books. This is a book on oxide nanostructures. You can go through, you can have a lot of idea how different products, devices can be made using oxide nanostructures. Although we are engineering materials lab, but we became more cautious during COVID, and we published books on advances in biomedical polymers and composites, and then the book on advanced materials from recycled waste, that is on waste to wealth, and advanced nanocarbon materials. So these kind of books from the CRC Press and Elsevier, this Taylor and Francis, these are the international publishers. They are publishing our books time to time. So in short, I will say that science and technology from lab to land, we are transferring, starting from fundamental research to applied research. Fundamental research goes into publications, applied research into patent, and the product, which is technology, and that is real translational research from lab to land. We do using these thrust areas like lightweight materials, nanomaterials, smart and functional materials, waste to wealth, and contribution towards society development. And this all overall it contributes in some form or other to make the country more and more self-reliant, Aatmanirbhar Bharat, in terms of economy, demography, infrastructure, system, and demand by our technological innovations. So with this, I definitely like the statement of Honorable Prime Minister, which he gave on 2nd March 2022, that science is universal, but technology must be local. Technology is for ease of living, for common man. With this brief note and a message to all young students who are listening this lecture, that science and technology is the pillar of the country. For growth of any country, science and technology is the pillar. So we should always try to contribute in this direction. आप सभी को धन्यवाद. Thank you all. जिज्ञासा प्रश्नों के लिए संपर्क करें. For queries, contact please director @ampri.res.in. Namaskar.
Thank you very much, Dr. Srivastava, for a wonderful glimpse. Today we really enjoyed a lot today's session. Dr. Srivastava, बहुत मजा आया. And viewers, you might have noticed that what Dr. Srivastava was talking about throughout his session, throughout his deliberation, is a synergy between science and technology. Modi ji's statement has been elaborated by Dr. Srivastava, but there are different sayings as well. Science today's science, another statement which goes hand in hand with all these things, which you are doing, in fact, at AMPRI. In fact, the whole CSIR is in it. The today's science is tomorrow's technology. It doesn't stop here itself, but you move ahead that today's technology gives birth to the tomorrow's science. So you are working with the tunneling microscopes, scanning electron microscopes, etc. Here lies some questions which I have been receiving from our viewers through different modes. I will try to take up all those one by one. Let us see how much we can take. One particular statement, that when you talk about scanning electron microscope, Dr. Srivastava, and then you talked about scanning helium ion microscope. In our school parallels, students often take helium ion as an alpha particle, but you didn't use the word alpha particle. So is it the single ionized helium atom you are talking about, or what is it?
It's a helium ion beam which we use. Beam.
So it's not how different it is from alpha particle beam.
It's not, alpha particle is a single particle. Here the helium ion beam, when we talk, it has both wave and particle nature.
True. This is the basic
Yes.
understanding before the definition.
Yeah.
So as far as I know, Doctor, viewers, these here you use not only alpha particles, which are doubly ionized helium atoms.
Yeah.
Here you use 2He3, which are singly ionized helium atom. So this is why we do not use it to be a alpha particle here. Yes, it's a greater probe because it has much higher mass than an electron is concerned, and therefore it gives us
Better resolution.
Yes. Better resolution. True. Another is yes, I must appreciate that you talked about the mechanical properties of the materials, particularly and AMPRI's contribution, towards the civil engineering structures, building materials, etc. You in between you talked about thermal properties of materials with the graphene composite materials. You used the word aluminium silicon alloy. For as far as one child is asking that aluminium, there is another set of composite material which is called aluminium magnesium alloys, which are much lighter in weight, much lighter in mass, so density is much lighter, but the mechanical strengths are as good as what the iron has. So in fact, the future researches, as we see in the journals, these are the points which I am receiving from our children viewers here. Many spacecrafts do use aluminum magnesium alloys so that they can have lighter weight but the same mechanical strength as the iron has. So there has been emphasis of using aluminum magnesium alloys in our vehicles. Though you talked about in the buildings, I mean, how far India has moved ahead in this direction, or what is the state of the art in this?
See, even if you see globally, first we started with steel because good strength and in all aspects good, but then we move ahead to lightweight, high strength to reduce this fuel consumption.
True.
So lightweight alloys are important. So from steel, scientists have started working on aluminum alloys. Now in aluminum alloys there is a series: aluminum lithium alloys, aluminum silicon alloy, aluminum magnesium alloy, and all those things. Now, but when it goes to the a real application, roadside application, when common man has to use, the property of the material has to be perfect from all directions. Not only in terms of density or not only in terms of mechanical property. It has to have thermal stability, it has to have mechanical stability, it has to have
electrical
stability, corrosion behavior, wear property. All those properties needs to be optimized before it goes for application. Industry will not take up your material just because your material is good in one property. It has to be optimized. So that is why aluminum silicon based silicon carbide metal matrix composites. Now it has come up, as I said, one example of using that manhole cover. Another example, we are using this, it is still under testing with Tata Motors, to use as brake drum for any crash worthiness. You know that you use that bag, airbag. Airbag can also be replaced with this aluminum based foamic material.
Yes.
Okay. So airbag, when you add airbag in your car, that company person will say it will cost another 50,000 to 1 lakh rupees. But when you use this aluminum based foam, it will cost 4 to 5,000 rupees.
Much lesser. That's
Much lesser. So and when there is, it should not happen, but in case any crash happens, then airbag will also go and this will also go. You have to replace. So when you replace it, it will cost around only 4 to 5,000, or at the most 10,000. But airbag will cost about 50,000 to 1 lakh rupees. So that is where a big advantage, cost effectiveness also comes into the picture.
So that's great. You are making us acquainted with this modern researches and modern industrial researches. I am particularly amazed to see and from your deliberations today, Dr. Srivastava, that how the science is working hand in hand with the industries. The transfers, the technology transfer, the knowledge transfer,
research,
the
yes,
translational
yes,
research
yes.
you have mentioned. These are really amazing. You talked about graphene masks. The question comes to our mind, to a layman's mind, how economical these are, number one. Number two, does it really going to increase the life or the reusability of the mask? Because the normal kind of mask which we use have certain life. Surgical masks are only for one time use, N95 for 4 or 5 days we can use with proper care. What about these graphene masks?
Graphene mask also has got life. It is reusable, and graphene has also got antimicrobial activity. So using that concept, one can coat your a particular kind of paper sheet on that graphene, and we have tested it and it is functioning very well.
That's
now we are testing with the help of AIMS Bhopal also.
Yes, you mentioned about
yes,
this.
yeah. So that work is going on.
Yes, so graphene is a wonderful material. In fact, so when the name graphene comes up, when anybody hears the name of the graphene, many questions come up because it's very thin. Even the thin sheets of say of 10 microns or so.
No, it's in nano scale.
Yes, you are right, nano scale.
Yeah,
so what you are using in mask are the nanometers graphene or?
That graphene deposition will be in nano scale only.
Okay.
It will be on some sheet.
Okay.
It's still IPR issue, but it is a sheet. On that you coat this graphene layer.
So what is the base material, sputtering material you use in this? Graphene is the coating.
Graphene is coating, and base material is comfortable with your body. But it's an IPR issue, so
okay,
it's
so that cannot be mentioned.
It's still under investigation.
No problem. We can understand these IPR issues, and we respect those. You took the name of All India Institute of Medical Sciences at Bhopal. You mentioned right in the beginning of your talk the roads you have prototyped therein. Are these associated with agro-based materials or some plastic waste as such?
See, we converted fly ash. It's a waste of thermal power plants.
Yes.
It's millions of tons fly ash comes out. So using class F fly ash, it has got a particular composition and it is available in big amount. Huge value in Hindalco, Nalco, Balco, all those companies. And that fly ash, using there is a particular technique, geopolymeric technique.
That
using that, you convert it cement-free concrete. Now, when you use cement, suppose you produce 1 ton of cement, equal 1 ton of CO2 also you produce. Right. Okay, so equal amount of that CO2 goes to atmosphere, which you inhale. But in this case, when you convert fly ash into cement-free concrete, 80% reduction in CO2 emission.
That's great.
First thing. Second advantage, that it is waste to value-added material. You are converting waste to value added. Now when we use this material, in AIMS Bhopal, we made a patch of that road, and it's functioning very well. And I mean, it is giving much better properties than the cement-free concrete, because parallel both the roads are there. And you know, sometimes need-based research. COVID attracted us more towards at AIMS Bhopal. We started working together. We signed MOU to work on certain topics like disinfectant boxes, this mask, and many other things. Even 3D, that dental thing also we are doing
Implantation.
now. Yeah, those things we are doing. So we are having very close collaboration with AIMS Bhopal.
Yes, I mean that is another area we look for interventions of CSIR's AMPRI, not only AMPRI but other laboratories of CSIR and other laboratories of Department of Atomic Energy, etc. in the country. Now we are running short of time, sir. If you have one question,
मुझे आप दोनों को लगता है कि ये जो साइंस का डिस्कशन चल रहा है, दो साइंटिस्ट के बीच इसे इंटरप्ट करना पड़ेगा क्योंकि समय की अपनी सीमाएं हैं। एक जो विद्यार्थी की जिज्ञासा है, आपने जिज्ञासा कार्यक्रम के बारे में बताया, बस मैं प्रिसाइजली जानना चाहूँगा उसकी तरफ से, हरीश उसका नाम है, कि ये जिज्ञासा कार्यक्रम क्या है? ये CSIR की शुरुआत है या AMPRI की शुरुआत है, और इसमें बच्चे कैसे पार्टिसिपेट कर सकते हैं?
नहीं, ये CSIR की शुरुआत है
जी,
और it's I think 5 years, more than 5 years completed when Ministry of Science and Technology and Ministry of Human Resource Development that time, they
now Ministry
both,
of Education.
yeah, they both signed MOU that CSIR Jigyasa, this Jigyasa program will be run under CSIR umbrella, encompassing using all 37 labs of CSIR. Okay, so we are also one of that entity, and based on your expertise, what expertise you have, based on that expertise, you run that program. So we have taken the charge of Madhya Pradesh, Chhattisgarh, and to some extent Odisha.
Okay.
So that is our responsibility.
That's great.
To reach to Kendriya Vidyalaya students and Navodaya school students.
That's great.
And by now, in last 4 to 5 years, we have reached more than 1 lakh students.
That's great.
I think that is the record.
That's the great.
In
Yes,
CSIR.
yes, that's ISRO. Some of the ISRO laboratories are also part of this Jigyasa program.
Yes.
Particularly the PRL, Ahmedabad.
Yes.
And other solar observatories of association.
So we
PRL,
conduct online program because of COVID, but again we have started this offline.
हम फिर से on track आ रहे हैं.
So they come to institute, they see the instruments, and they get feeling of that instruments and
जी
facilities.
बिल्कुल। डॉक्टर अवनीश, मुझे लगता है कि आपका जो ये शो है, हमारा जो ये सेशन था, इसको यदि मैं वेस्ट टू वाव की संज्ञा दूं तो बहुत ज़्यादा बेहतर होगा, क्योंकि ये वाव हम सबको चाहिए है। वेस्ट बहुत ज़्यादा हमारे जीवन में निकल रहा है, वो हमें लगता है कि उसे हमें कैसे रिड्यूस करना है, इसके समाधान भी हमें ही तलाशने होंगे। जैसा कि आज वैकल्पिक समाधान आपने देखे कि कैसे पराली से आपने एक वैकल्पिक लकड़ी तैयार की जिसको कई सारे उपयोगों में लिया जा सकता है। डॉक्टर गगन, मैं आपसे निवेदन करूंगा कि कंक्लूड करें।
Yes, thank you, Rahul, and thank you, Dr. Srivastava. Indeed, we thank CSIR AMPRI and Council of Scientific and Industrial Research Headquarters at New Delhi for collaborating with us in this webinar series. We are doing it with viewers. You know that we are doing this series in collaboration with CSIR and Prabhas portal of the Government of India, which is governed by CSIR at this time. So we are going to come back again to you, my dear friends, colleagues, and on 12th of August, when we are going to have Professor Shalivahan from the Indian Institute of Petroleum and Energy, which is another institute of national importance in India. Dr. Shalivahan will be with us in the studio, CIT studios, and he will be discussing about the geophysics, knowledge of depth, Bhubhat ki ek Singhavalokan. Shalivahan has been with the Indian Institute of Science, Indian School of Mines at Dhanbad for a long time. So looking forward meeting you again on 12th of August. Till then, bye. Goodbye. Namaskar.
Namaskar.